If the roots of the equations, the following equations are equal, prove that 2b equal to a plus c. So here again we compare the given equation, compare equation with, I've got to use capital here because small has already been used, ax square bx plus c equals 0, which means this is my a, b minus c, this is b, c minus a, and this is c, a minus b. Here now the roots are equal. If the roots are equal, we know that d is equal to 0, which means b square minus 4 ac equals to 0. Now let's put the value. The b we know is c minus a the whole square. Here is the b. Minus 4ac. This is a and this is c. So b minus c, a minus b equals 0. Now we go ahead. C minus a the whole square. A minus b the whole square. A minus b the whole square is a square. B square minus 2ab. Now minus 4 and I open the bracket. First I do b into a minus b and minus c into also a minus b equals 0. So again c square, a square, 2ac minus 4. Let me open this bracket. B into a is ba, b into minus b is minus b square, minus c into a minus ca, minus c into minus b plus bc equals 0. Now c square plus a square, this I just copy it out, open the bracket, minus 4ba minus into minus plus 4b square minus into minus plus 4ca minus into plus minus 4bc. Let me look and see if there are any like terms here. And yes, there are. There's ac here and there is ac here. So I put them together. So here I have c square plus a square. Now minus 2ac here and plus 4ac here will be plus 2ac. The rest I just copy it out. Plus 4b square minus 4bc equals 0. I'll rearrange this so you have c square, and you will know why I have rearranged later. This 4b square, I'm going to write it here, and the rest I will write 2ac minus 4ba minus 4bc equals 0. Before we go ahead, let us recollect an identity that we require here. We know a plus b plus c the whole square equal to a square plus b square plus 2ab plus 2bc plus 2ca. Similarly, if a square b square plus 2a plus c square, we have missed the c square here, okay, is given to you, a square b square plus 2ab plus 2bc plus 2ca, and c square is given to you. Back again write a plus b plus c the whole square. Now I'm going to write this expression in the form of a square b square c square plus 2ab plus 2bc plus 2ca. So here will come my c, that's a square, b square, and here will come 2b, this will be 2ab, so ca, and this will become here, this will be a, 2b, and here we'll have 2b and c. And if you notice here, this term has to be negative. Wherever there is b, it has to be negative. So when I put this together now, I got ba plus c plus a minus 2b the whole square equals to 0, because the roots are equal. So this was the expansion. This was an expansion of c square, a square plus 4b square. All that was an expansion of c plus a minus 2b equal to 0. So we have c plus a minus 2b equal to 0, c plus a equal to 2b, and we have proved it. Just to explain this again, so when we are given a square plus b square plus c square plus 2ab plus 2bc plus 2ca, we can write it as a plus b plus c the whole square. And that's exactly what we have done. We had here c square, and then we had a square here, and then we have minus 2b the whole square, the minus is in, then plus 2ab, c, and there was a, and then here we had plus 2, and we had a minus 2b plus 2, we had minus 2b into c, and that all we could write it as a plus b plus c the whole square. If the roots of the following equations are equal, prove a over b equal to c over d. So again we got to find the d, and to find the d we need to compare equation with ax square plus bx plus c equal to 0. So I'm comparing, our a is here, a square plus b square, the b is equal to this, that is minus 2 ac plus bd, and the c is equal to b square plus d square. It's given to us roots are equal and real, which means the d equal to 0, and we know the d is b square minus 4ac, and that is equal to 0. Now the b is here, this is our b, so minus 2 ac plus bd the whole square, this is our b square, minus 4 ac. If you see our a is here, that is a square plus b square, and c square, c is here, d square equal to 0. Now we need to solve this. Minus 2 the whole square, minus 2 into minus 2 is plus 4, and this is ac plus bd the whole square minus, let's open this bracket, a square into d square will be a square b square, and then we have a square d square, then b square. Here is a mistake at this point, this should be c square. Again your c will be c square plus d square. Here again the c is c square plus d square. Now when you open your bracket, minus 4 here will be a square c square plus a square d square, b square c square plus b square d square. Now take the 4 common out, and here you get ac plus bd the whole square, and the 4 is taken common out, so I have here a square c square plus a square d square plus b square c square and b square d square. Now this is equal to 0. I can ignore the 4 because I've taken it common out. So what happens now, I'll now open this bracket, ac plus bd the whole square, a square b square plus 2ab. Now open the bracket, minus a square c square minus a square d square minus b square c square minus b square d square equal to 0. There are a few things I can cut. I can plus and minus, I cut this out, plus and minus, I cut this out also. Now what remains is 2abcd minus a square d square minus b square c square equals 0. In this, if I take minus common out, what will remain is 2abcd plus a square d square plus b square c square equals to 0. Now since I've taken minus common out, I can ignore it, so I'm left with 2abcd plus a square d square plus b square d square equal to 0. And if you see this is nothing but a minus bc the whole square. Let me go over this. It was a square b square minus 2ab will be nothing but a minus b the whole square, and this is equal to 0. So AD minus BC equals 0. So AD equal to BC, which means now cross multiply, this B will come down and this D will go on the other side, and I've got my answer. Here in the beginning I made a mistake, so please correct it. This should be C square. So the C is C square plus D square. Here we get our answer.